Now let's go ahead and see how to find the inverse of a function in algebraic form. So there are a couple of steps involved in this. So let's go ahead and start with step one. I'm going to go ahead and write down my function here so it makes my life much more easier. I have my function f of x is equal to 3x minus 1. Step one is to change your f of x to y. Y is equal to 3x minus 1. Step 2 is to solve for x. Solve for x. So I have y is equal to 3x minus 1. Add 1 on both sides. And I have 3x is equal to y plus 1. I'm going to move this all the way up here. I have 3x is equal to y plus 1. And remember, I'm trying to solve for x, so I divide by 3 on both sides. And what do I have? I have x is equal to y plus 1 over 3. Once you get to this point, once you get to the point where x is by itself, you're almost done finding the inverse. But how do you write that? You write it as f inverse of x is equal to, now you're going to replace your y with x, because remember, when you're talking about the function f inverse of x, everything has to be in terms of x. So x plus 1 over 3. So your final step, your step 3, is to replace your y with x. And that is your inverse function. Now let's go ahead and take a look at the next one. Again, I like to write it down. So my function f of x is equal to x cubed minus 1. Step 1, I replace my f of x with y. Y is equal to x cubed minus 1. Step 2, I solve for x. So I have y is equal to x cubed minus 1. Add 1 on both sides. What do I end up with? Y plus 1 is equal to x cubed. Remember, I'm trying to get x by itself. This is a cube. How do I make sure x is by itself? I cube root on all sides. Cube root is equal to cube root of x cubed. When I find the cube root of x cubed, what do I end up with? X is equal to y plus 1 cube root. And once you get here, you are almost done. You just have one more step. What is your step? You write your f inverse of x is equal to, remember, you cannot have any y's. What do you write this as? X plus 1. You have to replace your y with x. And this will be your final answer. Okay, step 1, you change your f of x to y. Step 2, you solve for x. Step 3, you write it as f inverse of x, and you replace your y with x. Now let's go ahead and do one more problem. I'm going to write down my problem. F of x is equal to 4 over x plus 9. Step 1, change my f of x to y. Step 2, solve for x. So I'm going to add, let me rewrite this. Y is equal to 4 over x plus 9. I subtract 9 on both sides. What do I end up with? Y minus 9 is equal to 4 over x. Now here's the trick. As you can see, 4 is in the denominator, and I'm going to make sure both of them are fractions now. Because I don't see a denominator, I can go ahead and put a 1. And look what I'm going to do. I need to get x by itself. Now you can go ahead, cross multiply and do all of that, but I like to keep it simple. what I'm going to do is I'm going to flip this one. So look what's going to happen. Instead of y minus 9 over 1, now it's going to be 1 over y minus 9. When I flip one side, I have to flip on the other side of the equation. And what is this going to be? X over 4. And now, as you can see, your x is in the top, and all you have to do is simply cross multiply. And I'm going to make sure my x goes from here, my 4 goes from here to here. So all that is going to be, let me multiply, it's going to be 4 over y minus 9 is equal to x. Now you can say, Miss, what if I don't know how to do this part? What if you don't know, like, I don't think I can think of all of this, but what else can I do? So let me just highlight this one and let me show you. Let's go back to the problem here. I'm going to use black ink. Y minus 9 is equal to 4 over x. You don't know or you couldn't think of flipping. That's okay. You simply make sure you have your parentheses, multiply. So what is it going to be? X times y minus 9 is equal to 4. How do I get x by itself? Divide both sides with y minus 9, y minus 9. What do I end up? I end up with x is equal to 4 over y minus 9. Either way, anyway, you will still end up with the same value. And again, remember, this is almost your final step. This is your last but one final step. Once you're here, what do? You rewrite your f of x as f inverse of x is equal to 4 over, remember you cannot have your y's, it is x minus 9. And that is your final answer. All right? Now let's go ahead and take a look at this one. Same process. I am going to go ahead and, I'm going to go ahead and write this down. Y is equal to 2x minus 3 over x plus 1. It's already given in terms of f of x, so I'm going to change my f of x to y, right? Step 1's done. What is my step 2? Step 1. Step 2 is to solve for x. So when you have more than one fraction, you might need to pay attention because there are a couple of more steps involved. Solve for x. So what do? I'm going to make this a denominator. You know what? Let me rewrite it in a different color. Y is equal to 2x plus 3 over x plus 1. Let me go ahead and make this a denominator 1 and cross multiply. And now I want you to see what happens. Y times x plus 1. Make sure you have your parentheses, which is very important. If you don't have your parentheses, then there is going to be a difference in operations, like you will not multiply your y with 1, and there's a chance you might make a mistake. Now that I see my parentheses, I know I have to distribute my y. And what do I end up with? Xy plus y is equal to 2x plus 3. Remember, what is my goal here? My goal is to solve x for itself. That means I have to get all the x's to one side. But I do see that there is an x on the other side. I know I have to bring it to this side. So how do I do that? I will go ahead and, subtract 2x, subtract 2x. And now look what happens. 2x cancels each other. And I'm going to go ahead and rewrite this xy minus 2x plus y is equal to 3. And you know what I'm going to do? Because I don't have space here, I'm going to go ahead and take this whole thing all the way to the top. Again, let me recap. You subtract 2x from both sides. When you subtract, what do you get? You have xy minus 2x plus y equal to 3. And once that's done, I'm moving it all to the other side. And now, remember, the goal is to get x by itself. So I don't need the y here. I'm going to move my y to the other side. And now what do I have? I have xy minus 2x is equal to 3 minus y. I still did not solve for x, but don't you see there is a x and x here? What can you do? You can simply pull out the x or factor out the x. And now, is your x by itself? Yes. What do you do next? Divide both sides with y minus 2, y minus 2. And then what do you get? X is equal to 3 minus y over y minus 2. And remember, you're almost done. You're almost done. What is your last and final step? You will rewrite this as f inverse of x is equal to 3 minus, remember I cannot have any y's, over x minus 2. And that is your final answer. Again, I want you to pause, take a look at every problem here. The key here is to factor out the x. Once you know that you have to factor out the x, you're done. You're good with the problem. Okay, again, recap, take a look at every step, and that's how I want you all to do your homework. Now let's go ahead. This is the most good part of your inverse functions, graphing your inverse function. So here, use the graph of one-to-one function to graph its inverse. If I'm looking for a even function, it's symmetric along y-axis. If I'm looking for an odd function, it's symmetric along the origin. But if I'm looking for an inverse function, it is symmetric along the line x is equal to y. What is my line x is equal to y? How do I graph that? X is equal to y means when x is 0, y is 0. When x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. X is 4, y is 4. You get the idea. X is 5, y is 5. X is negative 1, y is negative 1. Negative 2, negative 2. Negative 3, negative 3. Negative 4, negative 4. So let me go ahead and join these lines. Okay? All right. Now you can go ahead and simply flip this. Let me show you step by step. I think it is going to be right here, and this is going to be right here. So I'm going to show you how this is done. So you can flip it, or you can say, Miss, how do I know my points? Let me show you the easy trick. I like to write down my points here. I like to write down my points. What is this point? Let me write this down here. The first point is this. Different color. The first point is this, and that is negative 3 comma 0. The second point is this, which is negative 1 comma 2. The third point is this, which is 5 comma 3. Remember, you're trying to find the inverse. When you're finding the inverse, your x becomes your y and your y becomes your x. This is 0, negative 3. This is 2, negative 1. This is 3 and 5. Let me move all of this to the side here. And that is how you graph your inverse function. Now let's go ahead and plot these. 3 and 5, 3 and 5 right here. 2 and negative 1 right here. Yeah, 2 and negative 1. 3 and 5, 0 and 3 right here. Now if I join this, boom, and from here I go right there. Do you see? It looks like the line has been flipped along y is equal to x, and that's how you find your inverse function. Now let's do one more. So this is my next, right? And here you can take your time to go ahead and look at the points. This is one point. This is another point. Where is this? 3 and 4. That's another point. Any points that you see, you can go ahead and pick them. What about 2? Somewhere here. Now you can go ahead and write these points. What is this point here? This is -1 comma 0. So my inverse is going to be 0 comma -1. And one point is 1 comma 1 right here. And the other point is 2 comma 2. And the other one is 3 comma 4, right? And I think I'm just going to keep it to that point. And this is when I flip 1 1, 2 2, 4 3. I always like to draw the line x is equal to y. Oops, wrong line. 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, yeah. And then look what I'm going to do. I'm going to flip this one along this line. When I flip it, instead of starting at -1 and 0, now I start at 0 1. Remember the inverse point? The next one is 1 1, same point. The next one is 2 2, same point. The next one is 4 3. So this graph will look something like this. All right, now let's go ahead and take a look at the other one. Here is my graph. Again, I like to draw the line 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, 1 1, -1, -2, 4. And what am I doing? I'm flipping this line. I'm flipping this line along this y is equal to x. Remember, this is the line y is equal to x. So this is, if you want, you can go ahead, pull out your points. But what I'm going to do is I'm going to just flip it. So when I'm flipping this, I'm going to start from here. Let's see. Not perfect, but I'm just going to bring this down here. And I'm going to flip this line. So you see that. Let me change the color here. Oop, wrong color. They both look the same. Now you see I flipped the line along y is equal to x. So there are multiple ways of doing it. You can go ahead, plot the points, or you can simply graph your line y is equal to x and flip your function. Now let's look at this one. When they give you points, it makes your life so much more easier because all you have to do is write these down. What's my first point? This is 0, 1. What is this one? -1, 2. What is this one? -2 and 4. When I'm finding the inverse, what do? My x becomes my y becomes my x, and my y becomes my x. Now let's go ahead and plot those. 1, 0. Very good. 2, -1. Very good. 4, -2. Very good. So how do I draw that? That's why you always need your referral line. Y is equal to x. Remember, how do you draw the line y is equal to x? Simply when x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, x is 4, y is 4. And how am I flipping this one? Let me use a different color. So your graph goes something 4, -2, this way. Let me make it thicker so you can see. Not close. What's going on? So let me go ahead and, yep. As you can see, now it looks like I flipped this entire line with respect to this axis, and this is what I got. And that's how you graph your inverse functions.